Hello friends, welcome back. In this session, we'll quickly understand what is confusion matrix, accuracy, precision, recall, and F1 score. We'll take a simple example, and through that example, we'll be able to understand all these flawlessly. Now, what's the goal? We must evaluate the performance of a machine learning model that we are developing. That's the major goal that we have in our hand. We must evaluate the performance of a machine learning model. Well, we are going to consider a case. We are going to classify if a person is affected with flu or not. That's all. If the test for flu is positive, then he has flu. He is infected. If the test for flu is negative, then the person has got no flu. He is not infected. That's all. He is infected or not infected. Now we are going to bring in machine learning to do this task. We will build an algorithm. The algorithm is going to detect if the person is infected with flu or not. That's it. The algorithm will do the task. Now we are putting ML into the picture, and the final output of the algorithm could be one of the following. First case, a person who is infected by flu, that is, the result will be positive and it is classified rightly by the algorithm as positive. He is infected, he is also identified as he is infected, and this is called as true positive. Remember, this is called as true positive. Case 2. A person who is not infected and he is also identified as person who is not infected after the test. So this is called true negative. A person is not infected who is also classified clearly as not infected, hence this is called true negative. The third option, a person who is not infected but he has been diagnosed as infected. He has been categorized as infected. So this is false positive. He is actually not infected but he is identified as infected, and hence this is false positive. And finally, a person who is infected and classified as not infected. A person is infected already, but he is identified as not infected. Hence, this is called false negative. So, we have got four very important terms. First one is true positive, second is true negative, third is false negative, and for false positive. So, four terms we have identified. Now, what exactly is the desired thing? We need the results to be only true positive and true negative. This is our expectation. It has to be true positive, true negative. If it is infected, yes, it is infected. If it is not, if it is not. As simple as that. But is this guaranteed all the time? No. Sometimes machine learning models can go wrong, right? Sometimes it classifies wrongly. So there is a confusion classifying if the person is infected or not. I have conveyed this in my earlier sessions. No machine learning model or deep learning model is 100% perfect. So a matrix helping you to describe the confusion prevailing over classification, whatever we have discussed, can be referred simply as confusion matrix. That's all. A matrix helping you to describe this confusion, whatever we have been facing in this scenario, is called as confusion matrix. Very nice. Now, we will take an example. We are going to take 100 people as sample. In that sample, we have got persons who are infected by flu. We have got persons who are not infected by flu. We have got persons who have symptoms which is not flu. We have persons who are healthy. So consider it this way, 40% of this list which you have considered are infected by flu, 60% of which is not infected. Now we have got the ML algorithm and it has to predict the outcome. The outcome predicted is infected, which is positive, or negative. It is termed as the predicted label. Please understand, it is termed as the predicted label. And the true outcome is called as the true label. This is a very important terminology. Please understand, the outcome predicted, that is infected, positive or negative, is termed as predicted label, and the true outcome is called as true label. Now the confusion matrix is required to compute the accuracy of the ML algorithm, and whatever I have presented in front of you in the matrix format is called as confusion matrix. Predicted label versus true label, you can see true negative, false negative, true positive, and this is what is called as confusion matrix. We will go back to the same example. We have taken a figure as 100 people as sample. 40 are infected by flu and 60 are not. I told about this some time back. Now we have got the ML algorithm which has classified it, assuming that we have built an algorithm. Now 30 people as infected by flu is what is the result given by the ML algorithm, but actually it is 40. 10 people who are infected are classified as non-infected. So 10 has gone wrong. We are just assuming. Now on the other side, 55 people classified as non-infected and 5 classified as infected. Actually, 60 people are non-infected, but only 55 have been classified as non-infected and 5 has been classified as infected. Now, the true negative would be 55. 55 are classified as non-infected. False positive would be 5. False negative would be 10. True positive would be 30 because 30 people are infected really and that has been classified as infected. Now fill that into the picture, and this picture, whatever we have presented you in front of you, is called as the confusion matrix. That's all. This is very simple, and remember, this is called confusion matrix. Now can we define accuracy? Yes, this is one of the most commonly used metrics. It will help you in understanding out of all the predictions made, how many of them were true. That's all. We have made predictions. How many of them are true? We need to know that. Accuracy can be calculated easily with the formula true positives plus true negatives divided by true positive, true negative, false negative plus false positive summation. That's it. This is the formula that we need to use, and please understand accuracy may not be a good measure if the data set is not properly balanced. Well, what is precision? It will get you answer for the question out of all positive predictions we made, how many were true? Out of all positive predictions we made, how many were true? So true positives by true positives plus false positives. That's it. That is called as precision. Now, what is recall? Out of all the data points that should be predicted as true, how many did we correctly get predicted? Out of all data points that should be predicted as true, how many did we get correctly predicted as true? So recall is calculated with the formula true positives by true positives plus false negatives. And finally, F1 score. F1 score is a metric which combines recall and precision. So 2 multiplied by precision into recall by precision plus recall. That's all. We can use these metrics to understand how exactly your model has performed, and I hope this session was useful. If you have any questions about this, please ask me in the chat. I'll be happy to clarify. Thank you.